This is the 10-5 video part 1. We're going to start looking at some of the more basic ideas, but overall this section we're going to be using a lot of trigonometry in order to find the area of different polygons. So the first thing we have to know is we have to know within this polygon, what do we call certain parts of it? We've got some vocab words here. I know you've seen center and I know you've seen radius. Apothem, that's a new word. The apothem is going to be this dotted red line here, which is the line from the center of the polygon straight down at a perpendicular to one of the sides. So within any polygon, I'm going to have a number of different apothems. So like here, they've labeled one of them for you. I could also have an apothem here at 90 degrees, here at 90 degrees, up at 90 degrees. So I have a number of different apothems. It's just anytime I go from the center to the side at 90 degrees, that's considered an apothem. So from the center to the opposite side. Now I also have a radius though, and a radius goes from my center to an angle or a vertex of our polygon. So anytime I have from the center to an angle, it is a radius. From the center to the side, it is the apothem. And then obviously our last word is center, which is located at the very center of that polygon. So let me draw a couple other examples for you. Let's say we have a triangle. We're going to be dealing with regular polygons. So this is an equilateral triangle. My center is right here. That's about the center of that triangle. Maybe it's a little bit off, but that's okay. We're going to draw our apothem in, which is a 90-degree line from that center to the opposite side. And then we also have our radius, which goes from the center to our vertex. So the blue line is our radius. Sorry, that doesn't really look like an R. And then the red line is our apothem. I'll give you one more example. Do a square. If I have a square, my center right there in the middle, my apothem is going to be down with a perpendicular, and my radius is going to the vertex of my polygon. So those are 3 examples. You should have all of those in there because this vocabulary is extremely important. So it's something very good to have in your notes. Now we're going to look at something else. We're going to look at how do we find certain measures of these angles. And some of them you'll remember from the chapter we did where we had polygons. We had n minus 2 times 180, n minus 2 times 180 divided by n, 360 divided by n. These are all going to come back to us because we're looking for these angles within our polygon. All right, so the first angle I see I need to find in this example is angle number 1, which is this angle right here. And if you think back to when we were dealing with polygons, this is a pentagon. It is a 5-sided shape, and this angle 1 is called a central angle. So let's remind ourselves of that. Angle 1 is a central angle. And in order to find the measure of a central angle, you are going to use 360 divided by n. So in this case, 360 divided by 5 gives me 72 degrees. So I know that angle 1 is 72 degrees. Now, angle 2, that's this angle here, that angle is half of a central. Because if you look at it, it's this angle here, this central angle, but it's been cut in half by our apothem. So we now have half of that central angle. So we're simply going to take 72, because we already found our central angle, and we're going to divide that by 2, which gives us 36 degrees. And then our last angle, angle 3, that's located somewhere else. It's located, sorry about that, I clicked off on something. It's located on the side of our polygon. So this is part of an interior angle. I see it's not the whole interior angle though, because here's 3. The whole interior angle would be this right here. So what I need to do is I need to look for half of my interior angle. So thinking back to that one chapter an interior angle, so angle 3, is half of an interior angle. And we had a formula for interior angles. It was n minus 2 times 180 divided by 2. So we need to figure out what that is and then cut it in half again. So we're going to take 5 minus 2 times 180 divided by 2. We get 3 times 180 divided by 2. That's 270. But I want to cut that in half as well because I don't even want the whole interior angle. I just want half of it. So when I cut that in half, I get 135. So angle 3 is 135 degrees. So just to recap, angle 1 is a central angle. So all we do is 360 divided by n. Angle 2 here is half of my central angle. So I have to do the 360 divided by n, but I have to cut that in half. And angle 3, this angle here, is half of an interior angle. So I have to use this formula, n minus 2 times 180 divided by 2, but then I have to cut that in half again. So here's a problem for you to try. It tells you are dealing with a regular octagon. So go ahead and find your angle measures for 1, 2, and 3. All right, so the next thing we're going to look at is this formula for the area of a regular polygon. This is important. It has to be the area of a regular polygon. If we don't have a regular polygon, we cannot use these ideas. If we do have a regular polygon, then we have this thing called an apothem. We're going to take the apothem, we're going to multiply it times the perimeter of our shape, and then we're going to take half of that. So the formula you need to know is 1/2 AP. 1/2 apothem times the perimeter. So the apothem is just that piece in the middle. That's one of our new vocab words. It's just this piece right here going from my center to my side. My perimeter is adding up all of these sides. It's the whole thing. If I were to walk around this entire shape, I need to know what that length is. So in this first example, we're going to use 1/2 AP. Area equals 1/2 AP. I know that my apothem is 12.3 inches. That's this length right here that they gave me. So I'm going to plug that in for my apothem. 12.3 inches. And then my perimeter I have to calculate. But they did tell me that this piece here is 8 inches. So if this piece here is 8 inches, and this is a regular polygon, then I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Oh, that's right. They told me it's a decagon, which means 10 sides. I need 8 inches times my 10 sides. That gives me a total perimeter of 80 inches. That's my total perimeter for this shape. So that is what I plug in to this formula here, 80 inches. And then in my calculator, I multiply 0.5 times 12.3 times 80. And my answer then is that the area is 492 inches squared. Please make sure that you include the inches. It's so important. We've been dealing with that for this entire chapter. It's something you definitely have to have in your answer. It will not be correct. So just to recap, I use my formula 1/2 AP. They tell me my apothem is 12.3 inches. I just have to calculate that my perimeter is 8 plus 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 8, which is the same as 8 times 10, which gave me my 80, which I then plugged into my formula and multiplied to get my answer is 492 inches squared. So you've got this. You try here. Go ahead and do that. Bring it to class, and I will see you then.